How much do you have to trust your regression beta? This is a serious question when you are doing DCF analysis, valuation from value investors' perspective, like Warren Buffett, because regression beta is rather backward looking in the sense that it is based on historical return data. What you need is forward looking beta, because with value investors like Warren Buffett or Carl Icahn, you maybe change the capital structure, like debt and equity mix, or you may be changing the business mix, like going into different industry and then get out of a certain industry. Those industry exposure and then the capital structure affects beta. The problem is historical data does not reflect your future plan. And then there is something called bottom-up beta we're going to discuss, and then we will motivate, why we need bottom-up beta. In this video, we are going to talk about the problem with regression beta, even though it is a great measure of market risk. And I start the discussion with the Korean company called Amore Pacific, perhaps the biggest KBeauty company and a long history. And here you see Seokyeong-bae, the chairman, and then the stock price of this company over the past 3 years. So if you have to value Amore Pacific, what should be the beta that you use, And should you use regression beta? How much can you trust it, How much should we trust our estimated beta based on the past data? I estimated CAPM beta of Amore Pacific in the following slides. Now, KOSPI and Amore Pacific. So KOSPI index return on the horizontal axis, and then Amore Pacific return on the vertical axis. And day by day, and then over the past 1 year, if I run the regression using this characteristic line, and then I find out that the beta is 0.53. I can clearly see that it is less than 1, which means it's less risky than the market, the average, right? Why would that be the case? Naturally, everybody use cosmetics no matter what, right? Especially, during the recessions or boom, doesn't matter. Just keep on doing things like this, So it makes sense, right? But if I change the time period, sample period, to 5 years, and then run a regression based on weekly returns, then see the regression coefficient. It changes to be 0.68. It's kind of higher than 0.5. What about past 5 years, but monthly frequency instead of weekly frequency? I get 0.67, which is 5 years. That's almost the same number as this. But the point is, 1 year versus 5 year, we see some differences, And then, which should we use to value the company, 1 year, is it good enough? Or 5 years? 5 years may be reflecting the nature of business more consistently. Is that really the case? Or 1 year, is it good? Or any noisiness, any problem with this, in the sense that all of these are based on historical data only. It does not reflect the future capital structure or business exposure of this company, It's about the past. Now, let me give you another example. A competitor of Amore Pacific, APR Corporation. This is April, by the way, 2026. APR, April? This is a very brand new cosmetic company of Korea, KBeauty industry, star company, young CEO, and then it started as a private company, venture company, and then recently got listed in the stock market only 2 years ago. So you see the price performance, stock price, and then if I run the regression and then obtain the regression beta, you see the CAPM beta is almost 0.4, and then if I expand the observation I tried to expand it to 5 years, but no way, because it only has 2 years of data, trading data. Okay, it got listed 2 years ago. When it is a private company, you don't have the regression beta. That's another problem. You see that, right? And then less number of observations over 2 years of period, and then you see the regression beta being 0.61, and then the recent 2 years monthly frequency, then you see 0.35, okay, for the same company APR. We are talking about the same company APR, but what should be their cap and beta when you are especially doing the DCF valuation? Should it be 0.4 or 0.6 or 0.35? Which one do you have to use? Okay. Moreover, again, these are all based on historical return data, whereas you may consider a drastically different capital structure strategy or industry strategy. If that is the case, what should we do? Okay. Now, measurement error, first of all, that's the first issue. Amore Pacific. Each time you run the regression of cap and regression, you will see this kind of result. The estimate, beta hat, monthly frequency basis, 5 years, the point estimate is 0.666. And then you see standard error reported in the table. And then the t-statistic, which is beta hat divided by standard error, which is 3.3. And then accordingly, the p-value based on this t-statistic is 1 out of 1,000. Okay, and then it gives you a lower bound and upper bound of 95 confidence level. If you remember what you learned in your statistics, right? T-statistic, critical t-value, right? The critical t-value times the standard error plus minus of it, okay, will give you the lower bound and upper bound, okay. Now, the question I'm trying to ask first is, what is the null hypothesis that we test with the t-statistics and p-value in each regression over here? You see p-value being very, very significant, and then you can reject the null hypothesis quite confidently. But what is your null hypothesis in testing these? Well, beta being equal to what? 0. Okay, is it equal to 0? 0.66? No. Okay, so we can reject the null that beta is 0. But it does not mean that the true beta of Amore Pacific is really 0.666. You see the difference here? Okay. It just confidently say that it is not 0, but where is the true beta? Where is the true beta? All that it says is that the true beta is really not likely to be 0, something different from 0. But does that mean that it should be our point estimate 0.666? Okay, it doesn't say that. Okay, it just gives you the confidence interval. Okay, it could be lower bound 0.269 and then upper bound 1.064. That is 95% confidence band. And does this confidence band include one market average? Yeah. All right. Can you confidently say that Amore Pacific is less risky than the market portfolio? And the answer is no. That beta 1 is inside the confidence band. Okay. And if I give you those statistics of the regression results using daily and weekly and monthly frequency for Amore Pacific and APR, you can see the regression tables like this. Okay. Point estimates, you already saw that. And then standard errors and t-statistics and p-values are shown like this. And then confidence band, right, varies depending on the time period and then the frequency of the sampling, right? Also, if the interesting thing is APR, okay? APR, if you go to monthly frequency 2 years over the past period, then you will see the lower bound being even negative 0.45. Okay, and then that means this is the regression line, characteristic line of APR based on these monthly frequency over the past 2 years. But the regression line is here, but the confidence band being lower bound being negative 0.45 means it can even be like negatively sloped. Okay, it's swinging too much, right? So can we reject the null in this case? The answer is we cannot reject the null. It swings too much, right? So very noisy. Okay, you can see the problem here. And then we call it, the standard error tells us about these noisiness. Okay, standard error. Okay, how much are you sure? How precise is it? Bigger standard error means less precise. Lower standard error means more precise. You see more tighter standard error, more confidence, more precision is going on. Bigger standard error, less confident. Okay, you can see that. And if you I ran CAPM regression for KOSPI 200 stocks that I gave you for the homework exercises. And here you see the distribution of the standard errors of these betas. Okay, you see all the standard errors are positive anyway, by the way. By definition, it has to be positive, but it has a distribution like this. Significant number of them have big standard errors like that. So the regression beta, it has a problem. The standard procedure for estimating beta is to regress stock returns against market returns. The slope of the regression corresponds to the beta of the stock and measures the riskiness of the stock. But it is noisy, number one. Okay, it has high standard error, as you've seen before. Okay, high standard error. And then it also changes the beta estimate. Okay, beta estimate also changes depending on the time you estimate the beta. Isn't it funny? Okay. Isn't the beta supposed to capture the riskiness of the business? That does not change. Should stay constant somehow, as long as your business character does not change and leverage does not change, right? But data itself is noisy, and then the standard error is noisy, and then depending on the time period, and really swings a lot. You see Amore Pacific, APR, LG Life and Health, and then Cosmax. These companies, rolling beta, okay, 1 year beta on a rolling basis, trailing 1 year data, and you estimate beta. Those are moving betas are shown over here, and you see even for Amore Pacific, this guy, it changes a lot. Sometimes it is close to 1.5. Oh my God, or even more than 1.5. And for APR, right, you see its beta became negative at some point. Why could it be? Well, that is the exceptional period when the stock market tanked, but the APR was really skyrocketing. It happens, okay? Negative beta happens even though the nature of it, the industry did not change. Very, very interesting. So noisiness is our first problem. The second problem is that it's not forward-looking, okay? It reflects the firm's business mix over the period of the regression, not the current mix, okay? Not the current or forward-looking mix, okay? It reflects the firm's average financial leverage over the past period rather than the current leverage right now going into the future. What if your leverage changed, okay? It's not properly respected. You just changed it today, it's not priced yet, or just priced and reflected in 1 day return, whereas your return data point is like 250, and it's just one data point, does not affect too much. So it's not forward looking. And then it cannot be, third problem, it cannot be estimated for firms that do not have stock returns. You saw that in APR. Over here, this is APR, and it's only 2 years data you have. What about the period before it got IPO? Okay, private company period don't have beta. Okay, so that's the problem. Okay, And becomes a problem if you want to work for a venture capital company or private equity company, because by definition, your portfolio companies will be not listed in the stock market. How would you value your company? Okay, so regression beta, current beta is a limitation for private equity or venture capital usage. Okay, is there any better approach to estimate a forward-looking beta? Can we estimate the beta for the firm from the bottom up without employing the regression technique? And this will require understanding the business mix of the firm and estimating the financial leverage of the firm. So the next video, I'm going to talk in more detail about these two aspects of it. Thank you.